Hello, everyone, and welcome to another episode of Echo Live. My name is Paulette, and I'm coming at you live from the Michigan Science Center. Here at the Michigan Science Center, I am our staff astronomer, but I'm also a volunteer for NASA's JPL. I am a solar system ambassador. So, as a solar system ambassador, I come at you guys with all sorts of really cool information. And what we're going to be doing today is we're going to be focusing on the Earth from space. So, if you have, this is the first time joining us, go ahead and introduce yourselves in the chat today. If you've joined us before, please introduce yourselves again. Welcome back. We love to see all of our wonderful Echo Live faces joining us every single week. So go ahead and introduce yourselves in the chat. That is going to be how I am going to talk to you guys during our program today. So, like I said, we're going to be focusing today on Earth from space. And you might see behind me something that looks kind of familiar, especially to us here at the Michigan Science Center. All right, check it out. What do I have behind me? Go ahead and type it in the chat if you know. We have Charlie joining us today. We have Rochi Sartori joining us today. Thank you and welcome. And of course, Miss Worth's class from California. Hello and welcome. You might not be quite as familiar as what's behind me, with what's behind me, but this is the state of Michigan. So in the state of Michigan, we're really well known for our Great Lakes. You can see that we are surrounded by those Great Lakes here in the state of Michigan. Now, if you are in Michigan right now, go ahead and tell me if you know what the weather is like in Michigan right now. Go ahead and tell me if you know what kind of weather we're having in Michigan right now. And you know what? It is cloudy and rainy. Michigan is a pretty wet state in general, mostly because we have all of those Great Lakes make it so that it's a pretty wet environment here in the state of Michigan. So today we're going to be focusing on some of that weather. We're going to be focusing on some of the things that we can see about the Earth from space. And as I zoom out, you're going to see all of our clouds pop back up, and you'll be able to see our Earth sort of just moving along. There we go. All right, so I have actually set us to a very specific date. But let's go back to today's date first. Let's go back to what we can see in about the Earth today. So today is April. Well, we're actually going to go back to April 27th, but here we go. I apologize. It's going to move really quickly, and then we are back to normal. There we go. And this cloud layer will take just a moment to load. But we're going to see what the weather looks like right now. So as it starts to load, our friends over in California, what kind of weather are you guys having today over in California? Here in the Midwest, it is rainy, wet, and cloudy. Some of our friends maybe over on the East Coast might be having some sun today and some warmer weather, but it looks like most of the United States is covered in clouds. Now, we use these clouds and all of the data that we see when we look back at the Earth. We use this data and this information to do things like meteorology. Meteorology is the study of weather. And Miss Worth's class, it is 90 degrees and sunny. We are definitely a little bit jealous here, although I'm kind of glad it's not 90 degrees here in Michigan right now. So we are going to take a look at some of the things that we can see on the Earth from space. And how do we find all of these different things that are happening. How do we look at the Earth from space? Here in our virtual planetarium, all we have to do is fly on out and look back. But I'm not sure if you know, the information that we are looking at right now is actually all live data that is taken from different data sets and satellites. So if we take a look at all of our satellites orbiting around the Earth, we're going to see that there are so many different satellites up there. And all of these satellites some of them are looking out into space. A lot of them are looking back to the Earth. Not all of them have imagery capabilities. So not all of them can take pictures, but some of them can. And specifically, there are two satellites that are looking back at the Earth called Aqua and Terra. Aqua is, of course, looking at the water. Terra is looking at the land. So we have some really great images from these different satellites that are orbiting around the Earth. Now, I said we went to yesterday's date because, of course, we don't have today's data yet, right? We're going to go back in time a little bit. We're going to go back to September 15th of 2020. There we go. We're back to September 15th of 2020. And part of the reason that I brought us back to September 15th of 2020 is there's some really interesting weather phenomenon happening, especially here in North America and here in the United States. This is not one of our mini-sodes. This is one of our longer episodes here today. So we'll be able to really take a look at some of the weather patterns and things that we see on the surface of the Earth. Now, part of the reason that I moved us back to September of 2020 is because September is smack dab in the middle of hurricane season. So hurricane season for us here in the United States and in North America goes from about June all the way through to November. And you might remember something about last year's hurricane season. We had a lot of hurricanes. We had so many hurricanes that we ran out of letters in our alphabet and had to start using a different alphabet to name them. We almost ran out of letters in that other alphabet as well. We had so many hurricanes last year. And with those hurricanes, we're actually able to see those hurricanes from space. Allowing us to be able to see those hurricanes from space gets us to study them a little bit closer. So if we take a look right down over here, we're going to see an example of one of those hurricanes. And if I continue moving out a little bit further, we're going to see so many. So we've got, let's see, one weather system, 2, 3, probably the remnants of a fourth. We had a ton of hurricanes in the Atlantic Ocean last year. So that allows us to really take a close look at these hurricanes, understand sort of what's happening inside of them, how the wind twists and turns to make these different cloud patterns that we see. So hurricanes are a really interesting thing that we can see from space. But you might notice something when we take a look at hurricanes here in the Northern Hemisphere and we compare them to hurricanes or weather patterns down in the Southern Hemisphere. Let's see if we can find a swirling weather pattern in the Southern Hemisphere. Let's see if we can find a swirling weather pattern in the Southern Hemisphere. All right, we're sort of seeing one right over here. Oh, actually way down over here, we're seeing one of those swirling weather patterns. So when we take a look at weather patterns from the Southern Hemisphere, we'll notice that they spin this direction. They spin in a counterclockwise direction. Whereas weather patterns in the northern part of the Earth spin in a clockwise direction. Why do we think that weather patterns in the southern hemisphere rotate counterclockwise and weather patterns in the northern hemisphere rotate clockwise. While we're thinking about that question and answering it, many of you may have heard that in the United States, our toilets flush a different direction than the toilets in Australia. And if you've heard that before, the claim is that because of something that we call the Coriolis effect, will force the water in the toilet to rotate the other direction because of the spin of the earth. Now, the toilet is not a really big body of water, right? So it turns out that that's actually not true, that toilets don't flush opposite directions. I mean, they might, but it's probably more about the shape of the toilet than the actual force on the body of water. But the oceans are a huge body of water, right? The oceans are a huge body of water. So that Coriolis effect, or the effect of the earth spinning on its axis, actually forces those storms to move in different directions. So remember, it is clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. So neat little thing that you learned today, and that is caused by, again, the Coriolis effect. Now, when we take a look at the Earth from space, not only are we able to see clouds, but we're also able to see some things that happen on the surface of the Earth. Now, if you remember 2020, not only was it a huge hurricane year, we had so many different hurricanes throughout the year, it was also a pretty massive wildfire year. There were wildfires that took place all over the West Coast. Our friends in California are probably very familiar with wildfires, much more familiar with them than we are here in Michigan. But wildfires are a big problem. Wildfires start and then they continue to spread and spread and spread. We can actually use some of the satellite imagery that we see to track the spread of the wildfires and to track something else as well. So if we zoom on in to our West Coast, we're actually going to see these wildfires in this part right here. But we see something else as well. Not only do we see the wildfires, but we see the smoke particulates as well. We can actually track what the smoke is doing and how it's moving across the United States. So for those of us in Michigan, you might have remembered that we went outside in September and the sunsets were beautiful. And that was because of the smoke from the wildfires from the West Coast. So even though we're all the way across the country here in Michigan, those wildfires still affect us because they're putting ash and particulates into our atmosphere. And it's moving all the way across the globe. So it's not just a problem here in the US, but it's a problem everywhere. And so if wildfires happen in other parts of the world, then we're going to have issues again here in the United States. This has happened in the past with volcanoes. So in Iceland, there is a volcano that went off a few years ago. And we were actually able to feel the effects of that volcano here in the US, especially over here on the West Coast. Because remember, if the volcano goes off all the way over in Iceland, it's going to take a while for it to get back to us in the United States because the Earth is rotating on its axis. And so it'll get to the West Coast of the United States before it gets to the East Coast, even though the East Coast is closer. So when we have super, super hot temperatures, we are really, really at risk of those wildfires. And like I said, it doesn't just affect the areas that these wildfires are happening, it affects the entire globe because of the way that weather and our atmosphere moves across the globe itself. Now, there's also some other weather that happens here on the Earth. We have weather like rain and clouds and snow, hurricanes, tornadoes, wildfires, all sorts of extreme weather and some not so extreme weather. We've got 90 degrees and sunny. That's not super extreme, although really hot. So sometimes, you know, here in Michigan, it was 80 degrees yesterday, nice and sunny. It's a beautiful day. So that is weather as well. We have extreme weather events that happen here on the Earth, and we have some not so extreme weather events that happen on the Earth as well. Now, on the Earth, we are also subject to something called space weather. Space weather is when the sun builds up a lot of energy. The sun is a super active star and it builds up a lot of energy. And sometimes that energy is shot off in what we call coronal mass ejections. Coronal mass ejections. That's when it shoots charged particles at us here on the Earth. But we have something called a magnetosphere. So we have something that actually protects us from those extreme space weather events. Our magnetosphere does protect us, and it moves some of those particles. It deflects those particles so they don't make it to the surface of the Earth. Now, some of the particles can actually make it to the surface of the Earth. And when they do, we see a beautiful space weather event called the Aurora Borealis, or the Northern Lights. There are Southern Lights as well. They're less common, and they cover the band where the Aurora Borealis or the Aurora Australis are in the Southern Hemisphere. Doesn't have a lot of people. So we tend not to talk about them when we talk about our auroral activity. But the Aurora Borealis happens where we do have a lot of people, and so we're able to see them pretty often. If anybody has seen the Aurora Borealis for yourself, go ahead and put that into the chat, because I've seen them. I had to go all the way to Alaska to see the Aurora Borealis. So it was an amazing thing to be able to see, but people can see them even right here in the state of Michigan. Usually they're in the UP or in northern Michigan when they see them, not here in the Detroit area. But please definitely type into the chat if you've seen the Aurora Borealis before, because you're one of the really, really lucky people that's been able to see that. So we did have auroral activity, and we had that activity just a couple of months ago. March 26th was a beautiful day for that auroral activity. So we're going to go ahead and move to March 26th. Again, it's going to take a minute for all of this to load. I do apologize. Like I said, I'm using a real data software called OpenSpace, which is available online at the openspaceproject.com. It is funded through a NASA grant, and is a really fantastic software if you are interested in exploring the universe, and it's free. So you don't usually get data-driven software for free, and this is something that I love using here at the Michigan Science Center. So we have our Earth here, but of course, we're not able to see the aurora during the daytime. It does need to be nighttime to be able to see it. So what we're going to do is we're going to move forward in time to be able to see what we can see on the Earth. So we're going to move forward an hour by an hour. There we go. You can see sort of that sun. You can see that the United States is starting to move into darkness. Let's see if we can get there. Whoa. So we're starting to be able to see what the Earth looked like that night. And there we go. We can almost see a little bit of activity. Now we can see the lights from the Those lights are from cities around the world. And if maybe we'll have to move back just a little bit. There it is. It is dark on this side of the Earth, but there is some light. So if we take a look, we're actually able to see up over here. It was on this date, March 26th. I'm also very, very turned around right now. I couldn't tell you if we are facing up, down, left, or right. So let me go ahead and get my bearings again. Now, the really neat thing about space is that in space, you can never really tell exactly what is up and down. And that is basically because there is no up and down in space. But it makes it a little bit harder when you're trying to fly around the Earth and see it in a different kind of light. Backwards just a little bit more. Oh, and there we go. There it is. Do you see up over here? These are the northern lights. So when those satellites were going over the top of the Earth, they were actually able to capture a picture of the northern lights. So those northern lights, again, are caused by these electrically charged particles moving in to the North Pole and South Pole because that's where the magnetosphere sort of converges. And it lights up particles in our atmosphere. Now, this was not a particularly big storm, so it was probably mostly green, so mostly nitrogen, maybe a little bit of oxygen in there as well, especially the upper part of our atmosphere. And we're able to see those northern lights from space, even this far out. You may have also seen images and movies from the International Space Station. Well, guess what? The International Space Station is orbiting around, and that's where we're getting our images from. So if I focus on the International Space Station, we zoom on in, we can actually see exactly what the International Space Station is looking at during certain times. And you might have thought that the International Space Station is really, really, really far away from the surface of the Earth. And compared to some of the other satellites that are out there, it's actually super, super, super close. So here we are zooming up on our International Space Station. And it flies over the surface of the Earth, just like all of the other satellites that are taking pictures. So on the International Space Station, we have cameras and we even have humans taking pictures back at the Earth. We can get real-time data from the International Space Station as well as those satellites of Aqua and Terra. So the Earth is a very interesting planet to look at. I know in our programs so far, we have gone to all ends of the universe. But one of the things that I really like to look at is I really like to look at our planet Earth because it's the planet that we live on. And it's the planet that we call home. So there it is with the International Space Station. Like I said, this software that I'm using is open space and is a really fun software to use. But look at these clouds in the ocean. Personally, I would love to fly on the International Space Station someday, although I'm really afraid of heights, so I don't exactly know how that would go. But there we are. Well, I want to thank you guys so much for joining me today. If you have any questions, please feel free to drop those questions in the chat. I hope that you enjoyed our journey looking at the Earth from space and some of the weather patterns, amazing weather patterns that we are able to see. While we're waiting for some questions, I do want to thank the Ford Motor Company and Denso. They are some of our sponsors here for our Echo Live programs. These are the programs that we're able to bring you every single Wednesday at 2:30 p.m. Eastern Time. And we are so happy to be able to bring these programs to you here from the Michigan Science Center. So not seeing any more questions coming in, I want to thank you again, and we'll see everybody